Welcome to this ATA Insights webinar. Thank you for your ongoing interest and support of our webinar program. Today's session will begin in 2 minutes. ATA Insights Webinars is an online platform for the dissemination of professional renewable energy knowledge across international borders. Our aim is to democratize access to information, for innovation to spread faster, and to make the industry more competitive. And we do this through our online sessions, open to all our members. Every year we do more than 100 sessions with over 250 speakers, 50,000 attendees from more than 50 countries. To participate in the session today, use the chat on the right-hand side to introduce yourself, your company, and where you're joining from. Under the screen you will find the Q&A box, where you can send your questions for the speakers. We will get to as many as we can today. We're recording this session and we will send you a link to the materials in a few days. Please consider supporting our content creation for the webinar program. Contact us on the email on screen.
Hello, everyone. Good morning or good afternoon, depending on where you are connecting from, and welcome to today's webinar. So as you can see on the image on the screen is on soil-free solar, and it's about how you can enhance the performance of your PV plants with the best cutting edge cleaning robots that we currently have. And we have with us three experts in this subject matter, and they will take us from the robots themselves, going through the design stage and then operations and maintenance, so like the implementation. So to start with, I will just ask each of the speakers to introduce themselves so you get to know them. Before I do that, I just like to remind you and encourage you to actually send questions through the Q&A box that you can probably see at the bottom of your screen. This is going to be, so sometimes we have webinars where you have presentations and then we have questions. Well, today it's going to be more of a conversation, right? So it's a roundtable discussion. I've got a few questions here for our speakers, but you can also send yours. So send them through the Q&A box, as they come to you, as you hear the experts speak. Well, we have a tradition here at ATA Insights that we ask all of the participants to introduce themselves in the chat. So go ahead and do it. Okay, enough of me. So I will ask each of the speakers to introduce themselves in the order in which I see you on the screen, which actually it matches both the cameras and the presentation. Well, first of all, welcome all of you, and I would like Sergio Villamarín to introduce himself. So Sergio, if you could tell us briefly who you are and what your experience is, that'd be great.
Hi, good morning or good afternoon, everyone. My name is Sergio Villamarín, and Matrix Renewables. I've been in Matrix for the better part of 2.5 years now.
Sergio, this is not law, but I'm having a little trouble
of the assets that we have
hearing you. Santiago and Olvia, are you also having trouble hearing him, or is it just me?
So do I, yeah.
Yes, and the attendees
I think
also confirm.
He just stepped out to reconnect. Yeah.
I see. Okay. Well, Sergio, we'll get back to you then. So, Olvia, if you could introduce yourself briefly, please.
Yes, hi everybody. Nice to meet you, and thank you for having us here. My name is Olvia Malagón. I'm technical sales manager for Arctech. Arctech is a tracker and fixed structure supplier worldwide. So happy to have this open discussion, kind of a panel, to get into the point of view of all of us, main suppliers, and the importance of having this into account since the beginning of the design of the project. Thank you.
Thank you, Olvia, and welcome to today's webinar. So, Santiago, if you could introduce yourself, please.
Sure. Okay. Thank you, Carlos. Thanks, ADA, for this slot. My name is Santiago Mussa. I'm the sales director for Ecoppia. Ecoppia is one of the pioneers and market leaders in autonomous robotic cleaning solution for solar sites. So it's really a pleasure to be here with some users of the technology, just as Matrix, with some of the main important suppliers of the sites like Arctech. So I think it would be a great discussion, and we are also looking forward to receive a question from the audience.
Brilliant. Thank you, Santiago, and welcome to today's webinar. Then Sergio, let's try again. Sorry, last time.
I don't know if I don't know if right now it's okay. I hope so.
Yeah, now is much better actually. So I can hear you clearly. So please go ahead.
Yeah, thank you, and sorry about before. It's the things that happen with the internet in live events.
Yeah.
Well, no, as I was saying before, I'm Sergio Villamarín, and I've been working in Matrix Renewables for the better part of 2.5 years now. And I have been centered into the operations and maintenance department in Matrix. So yeah, thank you as well to Ata and to Olvia and Santiago for the opportunity to be in this webinar as well. And yeah, I hope we have like an insightful discussion about this technology and all its applications.
Thank you, Sergio. I'm sure that it'll be a very interesting conversation that we'll have. So I'm gonna stop sharing my screen now, and I'll start I'll get the conversation going. So suppose that my first question is, what are we actually really talking about when we talk about cleaning robots? So if you, Santiago, I think you're probably the best qualified person to talk about that.
I think I'll take it from the technology perspective. Well, first of all, we need to understand what's our target, right? What's our scope? Why it's Ecoppia in the market? What's the need that we are chasing? What are we trying to solve? We see a lot of projects that are installed or deployed in very arid or semi-arid regions, because these are the areas worldwide in which the solar resource is the highest possible. So there is a lot of solar sites installed in arid zones, in semi-arid zones, and in that specific places, you can see two main things: that there is a very high soil in accumulation, that it's reducing the modules and the total plant efficiency, and there is also a lack of accessibility to water. So these are two things that we need to solve, because the panels are getting dust with the time, and we have no water resource to clean the panels. So we are decreasing our efficiency all the time. We are in very remote areas where moving people there, it's quite difficult. So this is where Ecoppia jumps in. Ecoppia jumps in 10 years ago with the first fully autonomous robotic cleaning solution. These are our very sophisticated robots that can operate cloud-based and can run through your entire site without the need of utilizing water. So that gives you the possibility of operating remotely a robotic unit that will do the cleaning cycle of your entire site within a day, okay, by just pushing a button with our interface system, and through our cloud-based operation, you can have our robots running at any time you want and then clean your site within a day or two. So this is what we are, and mean from our perspective, what we are trying to deliver to the market.
Great, thank you, Santiago. And in terms of the technology, so where are we at? What can these cleaning robots do? I mean, you've mentioned that they can help you clean a plant without water. They can do a number of things. So what is it that they can and can't do?
Again, sorry, the last part.
So what is it that these robots can actually do in terms of? So we're talking about where the technology is at, right? So you mentioned that they can clean without water, that they operate in remote areas. So.
Yeah, as I was saying, our robots, we have different family of robots. Okay, depending on the application, depending on the plan design. Maybe we can jump a little bit later on more technical things. But the technology is in a stage in which we can deliver you a robot that is fully independent from the energy. Okay, there's a robot that comes along with its own battery, with its own solar panel, that it will be installed in the torque tube or of your tracker. So it will be there installed on their own, and it will have the programming and the intelligence needed to step out from its docking station, we call the place in which the robot is parked when it's not running. So it would have the enough intelligence to jump out from that docking station, execute a cleaning sequence in the selected trackers, and come back to the docking. This fully autonomously and without human interaction. Okay, just by the request, by pimp the robot, by selecting the unit and asking to execute the cleaning sequence. And another thing that is very important, I think, in terms of where the technology is that we already have over 4 gigawatts installed in worldwide. Okay, we have tested our solution with PI Berlin, which is one of the most well-recognized laboratories in terms of solar industry. So we already confirmed that our robots are not damaging the modules. We work very closely with the trackers manufacturers such as Arctech in the integration of the solution to grant the customer a safety and reliable solution. And because of all these things, something that is very important when it comes to the time of implementation is that we are fully bankable. Because of our track history and because of the state of our technology and the integration we have with the other players in the solar sector, we have a fully bankable solution for the solar market.
Great, thank you, Santiago. And suppose my next question is about the when should cleaning robots be integrated? So how can you actually? I mean, I don't actually know how it works, so I'll leave all of the explaining to you. So how do you actually make sure that you get the most out of these robots and that they integrate with all of the other equipment that you have on a plant? I suppose, well, like the plant that you have on your behind you, Santiago, that's a very large scale plant. So, it's got lots of moving parts. It's got probably a very precise tracker as well. So from the design stage, how do you make sure that you integrate these cleaning robots to get the most out of it?
Yeah, I think I can step into that one. So I think it's really important to put the main focus where the most efficient time where we can make this compatibility between the cleaning robot and the tracker. Because even when we are starting the design stage, when we ask for all the geotechnical reports, hydrological topography, we start working the layout. And if we want to get into the most efficient or the most optimized design, considering since the beginning the use of robots, we should receive the specifications of which robots we are going to use, because in that way we are going to define the layout. This means we can make suggestions of which are the rows direction that we should use, because the robots go from tracker to tracker. So if we have the rows north-south and we have a bigger space, then the trackers can turn into exterior trackers that are bigger or that should resist highest loads. So we need to get the exact point during the design stage to confirm the compatibility of our tracker design and complete the layout design that take into account the use of cleaning robots, because there are main points that since the first stages of the project we need to take into consideration for a better design, most efficient layout, and that furthermore during Sergio in O&M, it is going to be easier to consider, for example, the cost during O&M, when since the beginning we have considered the use of robots, of cleaning robots.
So, I mean, if I was actually the owner of one of these large-scale solar plants, and I was actually thinking, okay, so you know, I hear you talk about design, that design is important. I suppose my first question would be, so what are the things that I need to take into account? And, you know, or what are the things that I should avoid? So how, in general terms, what are some like good practices for designing a plan with robots in mind to get the most, not only out of a robot, but actually out of a plant as well?
I think that at the title of this webinar, we are talking about cutting edge, the most advanced. So we want to have better compatibility between the main components. We want to have the best performance of our plant. We want to reduce the LCOE. So the main suggestion here would be that the use of cleaning robot is going to define in different points the final design of the tracker and the power plant. For example, Santiago is going to better detail it, but you have bridges between the modules so that the robot go through the tracker, or then you have bridges between trackers. So talking about Arctech point of view, our tracker has a single line of modules. This means we do not have gap, so we are reducing the bridges between modules. And then we have a specific tracker design that can have up to 4 strings per tracker. So you are reducing the quantity of trackers, and in that way you are reducing the quantity of bridges between the trackers. And another part of the cutting edge idea of getting everything more efficient is what the trackers or the main suppliers need to do to have the compatibility and to take into account that we are not like a single component that is going to be generating or reducing the LCOE. So in this part, I have already talked about the homologation or the compatibility with the cleaning robots. But on the other part, we have to do it also with the modules. Right now, the main idea or the main purpose of Arctech is take into account take care about the modules. So our stow position is almost flat. In that way, you are reducing the loads that the modules are receiving. So you are reducing the pressure that they can withstand, and everything is going to be like on the reliability side for the project. So everything, I would say that if we start considering which are the main components that we are going to use, we must have an homologation and a compatibility approval between the cleaning robot and the module and the tracker and the cleaning robot.
All right,
yes,
thank
and
you.
maybe just to complement
Go on,
a little
Santiago,
bit on Olvia's, so we can have a discussion. Just to dig a little bit more into what we say when we influence the design of the site, how to optimize. Sergio knows it pretty well. The less amount of robots that he has on the site, the better for him, but the less of the headache he will have in the future. So we need to try to find a way of arranging the layout in a way that serves of the purpose for everybody, for the tracker manufacturer, for the inverter manufacturer, for the maintenance road, but it should also consider that the robots, the fully autonomous solutions have the possibility, as Olvia was saying, to go from one tracker to the other without human intervention. But for achieving that, we should keep the design within certain constraints. So the distance in between the trackers should be up to a certain limit. And there are a few other considerations that we should consider that would lead to the minimal amount of robotic units. And what's the benefit of that? A best situation in terms of the O&M, a best return on the investment, because
the
you are
happiness of
investing
Sergio
less
is good.
for having the same.
Yes.
Sergio will be happy, and you're also investing less money, less robot for having the same results, because maybe a robot, instead of handling 2 trackers, with adjusting the design, it could handle up to 10 trackers. So imagine the difference in the capex you will be investing to get a robotic solution if you optimize the design. And this doesn't mean that we cannot implement robots in sites that are already constructed. We can do it. We can go to the site, we do the survey, we prepare you a proposal, a solution, and we deliver to you. But we have less, let's say, less capacity for optimization. If we get involved since the very beginning in the design of the site, together with the tracker manufacturer, together with Matrix, with Arctech, so we sit all together, and we understand the needs and we understand the issue better, we will for sure be in the optimal case and with a very positive return on investment and a very good influence on the site.
Brilliant. Yeah, it sounds like, it really pays off to actually start early and optimize the design for cleaning robots. And I'm sure that this is one of the aspects for everything else as well. But I just want to get Sergio involved because he's been very quiet, and also because he's the one who implements the robots inside, and he can tell us more about that aspect of these stories. So Sergio, tell us, what can these cleaning robots do for a plant in terms of, I don't know, whatever metrics you want to look at, the ones that are most relevant to you, but in terms of like efficiency of the modules, in terms of like how often you need to clean. Is Sergio with us?
I think.
Are you here? Your image is frozen, but yeah, I can hear you.
I don't know if you can.
I can hear you now.
Yeah.
Okay, now we can see you twice. Oh no, actually now once.
Yeah, I know. I had to change. I had to change because I ran into more problems with the internet, with the Wi-Fi connection. So I had to change to the mobile phone. I hope you can see me and hear me well now.
Now I can see you clearly and hear you like well too. So please go ahead.
Okay.
So did you hear the question, or do you want me to repeat it?
Yeah. I was thinking to start with talking about our perspective about what Santiago and Olvia told in their last answers, because I think for us is very important, as they said, for us is very important, not only from an O&M perspective, but also from an owner perspective, that we are in Matrix, that we are the owners of the projects. So whenever we are in the design process with the developer of the project, if we want to explore the possibility of installing autonomous cleaning solutions, robotic cleaning solutions, I think it's imperative that we have this coordination between, from one side, the robot manufacturer, as Ecoppia and Santiago, and from the other side, to the tracker manufacturer, in order to optimize, whenever it's possible, the layout of the plant, and also the costs associated with installation. And regarding your question, I think from an O&M perspective, we think that these solutions will deliver our assets mainly in 2 categories. The first one is obviously the economic one, because in this industry, I mean, it is very important that you look at minimizing your costs and maximizing your production and your revenues. But then from the technical side, and we can expand about the two later, but from the technical side, I think, and also from the O&M perspective that we have, where the plants are already in operation, the main thing is that the robotic cleaning solutions that we install allows us to limit the soiling accumulation in the modules, which, as I think everyone knows, is one of the main reasons for production downsides right now. I think in all geographies, and then for us, if you have the possibility to have robotic and autonomous solutions that you are cleaning the PV modules daily or almost daily, if you can limit the soiling accumulation and the production downside by implementing this solution. Also, that helps you with the preventing the degradation of the modules, and then because if you have a lot of soiling accumulation, then there can be hot spots, for example, that we cannot detect until we do, for example, a plant cleaning, a manual cleaning, and then we can see that there are some modules performing worse than others.
It seems like we are all worried about the modules here. So I think that, Sergio, you're right. We cannot have a tracker that can go like 90 degrees or the upside down. It is not possible. So that's why we think that having the cleaning robot is a better solution. So yes, for example, one of the main questions that we have been receiving, because we need to take into account like the kind of projects that we are starting to receive, both LATAM, Europe, and everything is related to the topography issues, for example. So it's like starting to have in mind that we are no longer in a new market or with new clients. We have already great experience to know what to do for a better tracking, or to take care about the modules with the large size, now to get a better performance during the O&M with the cleaning robots. And another main point that we are starting to receive is what we can do for the topography or the terrain adaptability. So from all the tracker suppliers, we are starting to implement some features that the tracker can adapt to these irregularities. But maybe, Santiago, this would be a question from me to you. Is there like a specific design where we have seen that the rover can go on a continuous slope, if we put it in that way? Mm-hmm. Can these robots adapt to, for example, a tracker that it is in different tilts due to the terrain?
Yes, for sure. Good question. That's a very important thing, because when you look at the robot, you need to design it in a way that it should be able not to run on the ideal site, but to overcome the different misalignments that you can expect to have. Misalignments in between the trackers, misalignments in between the modules, or even not misalignment, but slopes due to the topographic situation of the site. So we do have our technical specifications in which we define all these tolerances for the different misalignments. The robots are quite flexible, and they cannot overcome the general and the standard slopes that many of the trackers manufacturers designed their trackers for. So this is, let's say, kind of our input for our design. And for sure that we make all the structural designs in line and approved with the trackers manufacturers when it comes to the final design of a specific site. So this is a very important question. And the other part, there's a second part of this. We do not have a module representative here, but it's very important also for the customer to let them know that we are not damaging the module. Okay, so yes. So we need on one hand to certify our solution with the tracker manufacturer, misalignments, slopes, topography, and everything. So we can assure you that we are within the the tolerances of the site. And the second part would be the module manufacturer, because you have in the module, you need to avoid micro cracks, you have to protect the anti-reflective coating, so for not having a degradation on the module on the long term. So on that specific case, this is where we work in very close collaboration with the module manufacturer and with PI Berlin. We basically have tested with PI Berlin most of the tier 1 module makers in the market, and we have installed in a tracker a life accelerated cycle test in which we evaluate the effects of our patented microfibers running on a module, removing different type of soiling. We have included in the studio different type of soiling affecting the module. So what we have oversee as conclusion of the study after 10, 15 or 20 years of accelerated life test is that we are not damaging there's mainly no deviation of the capacity of the cell to absorb the energy after 15 or 20 years of operation of Ecoppia. And this is also a deliverable for the customer. I mean, when we do a project, we have all these module testers, so we deliver the PI Berlin test with a letter from the module maker that certifies that we are not damaging the module either.
Yes, it seems like we all want to make Sergio's during O&M life easier because, for example, if we have already installed projects without taking into account during the design stage that we were going to use robots, if you come to me and say, hey, we are going to start using a robot, I will say, maybe the structure or the modules is not compatible because for our design stage, we need to study or make specific calculations of the loads that the robot is going to impact in our structure. So it is a dead load. We need to know the wind speed of operating mode of the robot, which is the tilt that they normally work on. So I will be so sorry, Sergio, if in a project you come to me and O&M operation and say, hey, we are going to start using robots. And I will say, let me review if the calculations or the design of the tracker is suitable for using it. And not only the tracker, as we would say in Santiago and we were talking about the spaces, the gap between the tracker rows. Sometimes the bridges that they are called, or the docking station, Santiago, they won't have enough space. So that's kind of the main idea here, that to make the O&M life easier, since the design stage, we should start taking into consideration all of these variables.
That's really important for us as well, because what we are trying to do more as of now is to start evaluating the possibility of installing robots, as you both are saying, as early in the process or the design process as possible. Just not only as I said before, because we need to be in line with the tracker manufacturer, and also with the Ecoppia, with the provider of the autonomous solution, but also as Santiago was saying, the module manufacturer, because a lot of times we are running into the problem that we have a specific warranty with the modules as owners of the projects, and then because we did not disclose that we were using autonomous, we need the assurance that the usage of the autonomous cleaning solution will not affect the warranty of the modules, and that for us is very important. What Santiago was saying before, that they are also working with module manufacturers to ensure that the owners of the projects, aka Matrix, and the O&M people that we have in the operational phase of the plants have their life as easy as possible, and they do not run into warranty problems, for example.
Great, thank you, Sergio, and all of you. You've get the conversation going quite well. I think we should probably get to answer some of the questions, right, from the audience. There are quite a few of them. So let's start with the first one. from Yusuf Mutlu, and he asks, Mr. Santiago, if we want to clean panels in a solar power plant with more than 3 million solar panels, what kind of cleaning robot should we use? Ecoppia, of course.
Right, Ecoppia for sure. That's the first and as the most clear one. Well, but for 3 million panels, I think we're talking like around 1.5 gigawatts. So that's quite a site. That's really big site. But I mean, in general, and just to be, let's say, to reply in a standard way, I mean, our solution is completely scalable. Okay, so we design our robots to utilize and to be deployed and to utilize one robot in as much trackers as we can. Okay, so this is why we are making emphasis on how to design, on make the rows the longer possible and shorten the distance in between the trackers. So always we are trying to target, or our target is to try to have mainly 2 to 3 robots every megawatt. So that would be, let's say, the target for having a very good cleaning and optimal cleaning, a minimized amount of robots, an optimal return on the investment on this type of solution. So this is what we are targeting. And I have to say that regardless the amount of modules and the size of the plant, our robot, our H4, is able to clean 1 kilometer in 4 or 5 minutes with an autonomy of approximately 1.5 kilometers to 2 kilometers. So that could be done within a day. In 1.5 hours, you can clean that much amount of modules. So it doesn't matter which is the size of the site. This is fully autonomous. You do not need people there executing the task. So you can, sorry to be repeatedly, but you can fully scale this up, and you will have the same state-of-the-art solution for your sites.
Maybe the point of maybe the point of optimization there, Santiago, will be to try to reduce the quantity of robots, or like if you can adapt to any project, which I think, like, for example, Sergio, maybe you can step in. The best equation is to reduce the quantity of robots needed, for example.
Yeah. What we have seen is that it is the most economically advantageous for an owner's perspective is to reduce as much as possible the number of robots. That plays in 2 ways. You can, in the layout phase, maximize the length of the strings that you are cleaning, because if you can, with one robot, clean, for example, 5 strings, because the layout is put that way of the power plant, it is half the economic cost of, for example, cleaning 5 strings with 2 robots, because you have it in parallel, for example. And then also this, whenever you are already in operational phase, it is an economic save as well, because the maintenance cost of the robots, just because you have fewer robots, goes down as well. So the OPEX, whenever you are in operational phase, whenever you are already producing and generating revenues in the power plant, goes down as well. So the performance, the economic performance of your project also goes up, which is doubly advantageous.
Yes, Carlos, if I can continue.
I think of course,
we are all in the same line. In Arctech, we're, as I said, we're trying to reduce the quantity of trackers by getting like higher capacity trackers. This means being able to handle up to 4 strings, even with large size models. So in that way, again, we are reducing the quantity of trackers, we are reducing the quantity of robots needed, and also the quantity of the bridges between the trackers. So I think that's like a really good main point or equation where we can all be aligned since the beginning, and then the cost can be like optimized in the best way possible.
So yeah, I think, you know, these answers a couple of the questions that that have been asked here. So a question by Mohammed Hamdi, and he asked, could you please define how to decrease the number of robots with a tracking system? So I think, you've already provided some clues as to how to do that, right? So I think there is, a key question, which is, of course, a question on the functionalities of a cleaning robot, but also I think, it is important to understand this answer. So Sohaib Elias asked whether the robot shifts rows. So can it actually like go to another row, or how does it work?
Well, the robot what do basically is handle an entire row. So it could move freely in the north-south direction. So we can clean consecutive trackers. We are not yet in the phase that we jump on the east-west direction. We are working on some developments, but we are not yet there. Well, so when we talk about, because when you talk about something that is completely autonomous, you need to be fully reliable, because it doesn't work for the purpose of having something that you cannot rely 100% to move east-west if you do not have a very, very high reliability, because in the end, it will create human interactions for correction of these issues. So nowadays, what you can expect as a very, very high reliable and state-of-the-art solution is a robot that can move in the north-south direction freely, but not yet moving on the east-west direction.
Okay, well, I think that makes a lot of sense. There is another question here, so which is also, what is the source of power for your robots?
The robots are fully independent. I mean, they have a battery installed on it. It comes with the robot, but in what we call the docking station, which is essentially a very small structure in which the robot parks when it's not operating. There's a very, very small solar panel that is only connected to the battery of the robot. So it basically extracts the energy from its own dedicated solar panel without any intervention or interference with the rest of the hardware on the site.
Right. Okay. So it has its own panel, so it doesn't have any consumption of the plant, as it were.
Right. Exactly.
Okay. Great. Right. So there are lots of other questions there. There is a question that I always see on webinars about cleaning robots, is whether there are cleaning robots available in the market for bifacial panels.
Well, bifacial panels, they have, let's say, a constraint. I mean, the solution is available, but we just clean on the active side, and there's a reason behind there. What you can get as an extra production on the other face of the panel, it would be around probably 15 to 20% extra energy production. Okay. And the soiling impact on the bottom part of the module is much less affecting the efficiency of the panel than the front part. So you have the soiling that it's affecting the front part of the panel, which produces the 80% of the energy, and you have very less soiling affecting the other side of the panel that only creates a 15 to 20% extra energy production. And the effort that would require designing something to clean that back part of the module that creates such a less increase in the production, it just doesn't pay off. So we mainly focus on the front part of the module.
Right. Olvia, of course.
I think Olvia want to say as well about this.
Yes, so it's more related to what we are constantly receiving from the clients. But if Sergio, you were going to say something related to what Santiago just said.
Please. Providing my point of view about this, because in Matrix we have various projects with bifacial modules in different geographies as well. And all the studies that we have done is that the reverse side of the modules that are bifacial is not affected by soiling too much to be considered to be cleaned by an autonomous cleaning solution. So the thing is, you have to take into account other factors as well. For example, the albedo. There are geographies with higher albedo than others, so you can extract more production from the rear side of the modules. But in general, it's not as economically advantageous and technically positive to clean the rear side of the modules. Even with manual cleaning as well, it doesn't give you the upside, the sufficient upside to consider that.
Makes sense.
Olvia, I don't know, did you want to say something as well about this?
It's like another topic that I was reviewing with Santiago, and I think it's relevant for our customers to hear about. Is related to the best position of the cleaning mode. So what we in Arctech do, I think we are only two of us, we have changed our stow position into almost flat. So I was discussing with Santiago that they have specifically a robot that can clean in flat position. And I think it's like the best combination. We are getting the tracker into the safety mode, and that's the best position for the cleaning robot to make its job. So Santiago, I don't know, for example, we at night we can call it the stow position. The trackers go like this, and it makes sense to make the cleaning during the non-operational hours or not generating hours, so that we can make the cleaning job. So Santiago, I don't know, what do you think about it?
Yeah, no, I mean, it's always, I mean, we can clean while the site is tracking. We can do that. We have no problems with that. But we already understand that is let's say from the owner perspective, it's much better to have the robots running while the site is not generating. So after the sunset would be the ideal time. So you know that the tracker is not moving, the tracker is fixed, so you can have the robot going and coming and cleaning without any additional movement. So this is the ideal point, the ideal part of the day that we would decide to clean together with the owner. Okay. And then in such cases, we have different options. The stow position of the different trackers are different, the angles are different. So for example, with Arctech, we have the advantage that they have the stow position at 0 degrees. Okay, so if we are using our T4 solution, which is a navigable solution that navigates over the modules, it's a very lightweight robot that weighs only 12 kilos. So it can move along over the modules. We can clean with the tracker at stow position. So that's a very, let's say, easy approach, way forward approach. We do not have to execute any modifications. When the tracker is at stow, we go, we clean, we come back. When the tracker starts tracking, we are in our docking. So that's good. And the other option we have, in case we require any specific angle for cleaning, or the tracker is moved from the idle point, is request the tracker, the tracker SCADA, the tracker software, to move the tracker to a certain position within a period of 1 or 2 hours, so we can execute the clean, come back, and then the tracker will go back to stow position. But we are very familiar with both type of approaches.
Thank you, Santiago. There are a few questions here on soiling, and how do you estimate soiling, the amount of soiling or soiling losses on your on panels? And I suppose my question on that would be, yes, if you have some if you can give the audience an idea of how you estimate soiling losses, that'd be great. But also, how do you decide how often to clean? So how does it work in a normal plant, either a such thing? Do you clean every day? How do you make that choice as to when to clean?
Actually, most of the site owners, they measure the soiling on their own. That they have their own measurement devices, because when we were talking about manual cleaning, they also have to take the decision on when to clean. Sergio knows it pretty well, and he might can support us on that. But on the other side, you can integrate those measurements and understand how the robots are performing, because you will see that there is no decrease in the performance of the site. So that would give you an idea on which is the cleaning frequency that you may need to apply. Even considering that in general, we are talking on very arid and semi-arid zones. So we have the approach of cleaning every day initially. Why is that? Because we give you the possibility of having your models crystal clear the starting of the day. So we are removing the accumulation of the soiling from the day with our autonomous cleaning system. Is completely autonomous, so we do not require additional efforts from the human perspective. The robots will go out, will clean, and they will come back. So there's no, let's say, additional efforts on doing it one day after the other, and you would have your site at the top of its performance.
Mm-hmm.
Santiago. Sergio, please.
Yeah, I can add about this topic as well, because from O&M perspective, the measurements of the soiling in our power plants is a very important KPI in order to decide, as Santiago has said, when to clean and where to clean, because depending on the geography, as Santiago said before, we have almost arid geographies where the robotic solution allows us to clean every day, because there is the environment to clean every day and to maintain the modules clean without allowing the dust to settle in a way. And then we have to look, I was saying about the geographies, because we have to look also about the humidity of each environment, because Santiago can expand about this topic, because I think he knows more than me. But the humidity plays a part in the when you are accumulating dust in the modules. If you don't clean almost, for example, 1 day, 2 days after they are accumulating dust, the humidity of the environment turns the dust into some mud, for example, I think is the word to say, and that is a lot more difficult for a robotic solution to clean. So I think we are in the same page that if we implement a robotic solution, it is in the best interest of the O&M as well to try to clean every day possible, because it's almost the same logic as a manual cleaning. If you take too long without cleaning, then it's worse, and it's going to cost you more to have the plant at 100% production again.
Thank you, Sergio. Olvia, I don't know if you want to say something about this, or should I go to the next question?
We can go to the next question.
Okay, great. So there are a couple of questions on test standards for PV cleaning robots. So Munir Ibrahim asks, do PV robot manufacturers provide test reports of their own robots to potential clients? So so Santiago, you are the PV robot manufacturer. So what's your take on this?
So far we haven't seen a kind of a standardized for a specific norm for worldwide recognized for manufacturing of robotic cleaning solution for solar sites. Probably this would be one of the topics that we need to push as one of the pioneers on this industry. But what we do have been seeing so far in the last month is that many of the big players of the big companies that have a lot of assets worldwide is that they are preparing their own technical specifications that we need to fulfill at the time of presenting a bid. Same when you provide a tracker that happens to Olvia, you receive a technical specification with a lot of details that you need to fulfill. That wasn't happening before because it was such a state-of-the-art solution, so that even the customers, they do not have too much material to compile and to create a kind of requirement. But these days, with all the information that is available in the market, we see that most of the customers are providing us a technical specification sheet that we need to fulfill in order to provide a code. And in terms of safety reliability, we do provide and we do deliver the customers the supporting letters and let's say the compliance letters from both the tracker manufacturer and the module manufacturer, so they can be sure that we are in compliance with the requirements and we are not affecting either the modules or the trackers.
Santiago, I don't know if Olvia or Sergio want to comment on this.
Yes, I think that, as we have said since the beginning, we are no longer in a new market, in a new way of making projects. As far as we can start like gathering all the main inputs of design, we can get a most accurate design and most optimized layout, for example. So the compatibility or the tests that Santiago was mentioning are also responsibility from the tracker side, both with the cleaning robot and with the module. So we can ensure that the pressure that the module is going to receive is less than the one that they can withstand, and that we are compatible from the bonding between the tracker edges for the cleaning robot's performance. So I think that we can start taking into account the conditions of the projects that we are going to start working on: high wind speeds, irregular topography, soiling, and compatibility with the cleaning robots. So in that way, we can get that in place on an early stage and make a little bit more efficient transition to the O&M part with Sergio.
Brilliant. So there is a question here, actually, now that you mentioned, the environment and about it's from Felipe Astorga, and he asks whether dry cleaning is safe or whether it could damage PV panels in saline conditions such as those in the Atacama Desert. So what are your thoughts on this, Santiago?
Not only my thoughts, I would speak from the experience in the Atacama deserts. We have projects in Chile, close to Calama, and we are very familiar with the soiling that they experience in that area. I think it's what they call chusca in Chile, and we are very aware of the accumulation, of the composition, and we feel very comfortable by removing the soiling. This type of soiling we have tested and we see no issues. We are operating there with no issues. But something very important that I would like to point out is that we are not using brushes for cleaning. So a completely dry solution would not work with brushes for cleaning. This is what we understand. I know that there are different other solutions in the market, but we do understand that the autonomous, fully cleaning solution, dry solution, it doesn't work without brushes. You need some microfibers for executing the duty. So our microfibers are not creating any damage or abrasion either in the module, in the cell, or in the anti-reflective coating. This is also reflected in our PI Berlin reports, in our live accelerated test reports that we deliver with PI Berlin, and we can show that this is let's say part of our commercial information that we use when we deliver a technical proposal. We can show that as consequence, as conclusion of the studies we did on our products.
Brilliant, thank you, Santiago. So, well, we're actually coming up to the end of the webinar. Like all good things, this webinar also needs to end. So, I would like to ask you to, you like the speakers, right, to just give some last words for the audience to summarize what we have spoken today. So what do you want the audience to go away with? What do you want the main takeaway to be? So maybe we'll start with Olvia. So Olvia, what do you want the audience to go away with in this webinar?
Okay, I think that from tracker layout point of view, we need to have like a timely consideration of all the inputs, the modules, the studies, geotechnical, if we are or not going to use the cleaning robots, if we are going to mount the inverter on our structure, which kind of cable routing solution we are going to use. So all of these inputs, if we started taking them into account on an early stage, you are going to reduce the uncertainty, we are going to reduce the risk, and we are going to have an accurate design. And an accurate technical design means a specific cost for the capex of the project. So I think we need to have the compatibility between the main components. We need to start collaborating with these homologation letters so that our clients can be satisfied that and can be sure that it is not going to be any problem if the tracker is under high wind speed with a large size modules and using a cleaning robot, because all of that we are going to have it controlled from our side, and the performance of the plant can go higher. And that's what everybody wants here.
Yeah, thank you, Olvia. And Sergio, what would you say is the main takeaway that you'd like the audience to take with them?
Yeah, from an owner's from a project owner's perspective, we agree we agree a lot with what Olvia just said. It is really important to start evaluating the installation of robots in an early stage of the design of any PV plant, just because in the later stages, in the construction stage and also in the operating phase, which is related a lot to from an O&M perspective, makes life, not only life easier for everyone involved, but also drives costs down, avoids unnecessary or surprising costs that you have because you didn't plan before the installation, and then you are running into problems with integration of tracker with robot or module with robot and so on. And then from an O&M perspective, the main thing is, yes, we have or we would like to have autonomous cleaning solutions everywhere, but it is imperative that you monitor the soiling ratio of the plant and the soiling accumulation of the plant, just so you can predict when the robots are cleaning, and to maximize the production and also the performance, which are, as you know, the two main columns of any project which is in the operating phase.
Brilliant. Thank you very much, Sergio. And well, Santiago, what are your takeaways for the audience?
Well, I think it's really good to be all together, different views. Me as a technology, Olvia as another technology that is working together with us, Sergio as the asset owner. So I think that I mean the aim. I hope we meet the target. It was to provide you all with the big picture on how a robotic solution works, what it can deliver to each of the parties, what you need to consider, and for sure, if you need to deep dive on any of the topics, I think, well, I'm available, and I'm quite sure that Olvia and Sergio are as well, if they want to have further conversations. So that's the main goal. Hope we achieve it, and thank you very much for the invitation and for all the audience.
Brilliant. Thank you very much, Santiago, Olvia, and Sergio, for your insights today. So that's all. I'd like to remind everyone in the audience that this webinar was recorded, so you will get an email with access to the recording. And I hope to see you here next time. So check out the other webinars we have at atainsights.com, and we'll see you next time. Bye-bye. Have a good day.
Very much. Bye.